Good evening all. Today we are going to discuss multiple antenna transfer and receptions that is adapted by LT, and that we have to discuss. There we have the special diversity technique we are using to come over this problem. Multi-antenna transfer receptions. Basic concept of diversity: transmit the signal via several independent diversity branches to get the independent signals replica via time diversity, frequency diversity, space diversity, and polarization diversity. High probability all signal node phase simultaneously and deepest fade can be avoided. It provides protection against fade. Multiple antenna technique can be grouped into roughly three different categories. Diversity: it allows the number of different versions of the signal to be transmitted or received or provides considerable resilience against fading. Interference suppression and spatial multiplexing. What do we mean by interference suppression? It uses the spatial dimension to reject interference from other users, either through the physical antenna gain pattern or through other form of array processing such as linear pre-coding, post-coding, or interference consolations. Spatial multiplexing. It allows two or more independent streams of the data to be sent simultaneously in the same bandwidth, same time, and hence it is useful primarily in increasing the data rate. All three of these different categories are often collectively referred to as multiple input and output memo of communication, which is adapted by LT, and that is a wonderful characteristics of the LT 4G transmission. What do you mean by spatial diversity? You can see that it is having MISO, SIMO, MIMO, MIMO, MIU. You can understand multiple input, single output, single input, multiple output, multiple input, multiple output, multiple input, multiple output, multiple users. So this is we are having spatial diversity in four categories. Spatial diversity is exploited through two or more antennas which are separated by enough distance so that fading is approximately correlated between them. Array gain means a power gain of transmitted signals is achieved by using multiple antennas at transmitter and or receiver with respect to single input, single output case, SISO. In case of the simply called power gain, the array gain is almost exactly proportional to the length of the array. This provides performance enhancement of the coherently combine the energy of each of the antennas to gain the advantage versus the noise signals on each antenna. Array gain or correlated changes. This is defined by down equations. Here also you can see the equation. What is the conclusion? You can say that spatial diversity, the received SNR also increases linearly with the number of received antennas even if those antennas are correlated. However, because of the channels are all correlated in this case, identical, there is no diversity gain. What is diversity gain? Increase the SNR ratio due to some diversity scheme, or how much transfer power can be reduced when the diversity scheme is introduced without performance loss, expressed in decibel as in power ratio. This is known as diversity gain, and this is defined by down PB. C1, C2 are the constant of the above equations, depend on the modulation type. Receive SNR. Spatial diversity. Okay. Continuation of fading channel without diversity. SNR becomes random variable of fading channels, and so the BEP also random variable. Average BEP decreases very slowly and can be written as conclusion. The simple inverse relationship between SNR and BEP much weaker than the decaying exponential. Fading channel diversity is given by ND. Spatial diversity is given by increase the data rate of the spatial diversity is given by C B log 2 1 plus gamma. Increase and coverage area of the spatial diversity is given by the following. Consider simplify the path loss model. PR equal to Pi into P0 d to the power dash minus alpha. And this is the equation we are using for the diversity, spatial diversity. Thank you very much for your attending this particular